So yeah, we'll go into exponents and roots. So in the next slide, you'll see these are kind of the approximations. It's kind of good to know, and I think Mr. One is giving a good um, hint of how to get kind of close, which is um, instead of thinking square root of, let's say, 3 or square root of 5, think of more like square root of 300 and square root of 500, and you can think of numbers that get close to that. But yeah, so these are things that are useful to know. This will also be useful in some of the problems you'll see, but you don't have to worry too much about memorizing these, but it is helpful to know. I think especially square root 2 and square root 3, those um, are more useful. Um, but yeah, don't worry too much about memorizing them, but knowing them will help you on in the competition. So
Good. Yeah, I wanted to say something briefly for like square root 2. You can think of it as square root 200 or like square root of 2.00. And if you think about it, the perfect square that's closest to the square root of 200 is 14 squared because that's 196. Whereas if you do 15 squared, it's 225. And 196 is a lot closer to 200. So that's why it's going to be 1.4 versus 1.5. Okay. Next.
cool. All right. So now into some of the more of the concepts. So we'll be talking about we'll talk about exponents first. So this whole thing is they're sometimes called powers as well, and you'll have your base as well as the exponent, and hopefully, so from the previous lessons, you'll remember that these are like the factors. So 5 to the third power is 5 times 5 times 5. Okay, next slide. So the question is, so what if you multiply two of these? So can everyone please send me your guess for what this would be? So 3 to the third power, or 3 cubed, times 3 to the second power, or 3 squared. You can direct message me. So direct message Coach Homa. And you can, okay, cool. Okay, let's go to the next slide now. So missed on next slide. Yeah, okay, so you can think of this like, so 3 cubed is 3 times 3 times 3, and 3 squared is 3 times 3, and you're just multiplying all of these together. So in total, you're multiplying 3 5 times. So you can just say 3 to the 5th. So as most of you got, it's 3 to the 5th, which I think is also 243. So, oh yeah, also in general, when you're sending me answers today, if you want to type exponents, you can use shift 6 to do a caret. So if you wanted to say 2 cubed, 2 to the third, you would say 2 caret 3, and then 3 to the fifth would be like 3 caret 5. So this will be useful for today. So yeah, the rule in general is when you're multiplying things with the same base, you want to add the exponent. So this is how we might use variables, how we might use letters to represent what we're saying. So this just means like you can say x can be like 3, a can be 2, and then b can be 5. So you're saying 3 squared times 3 to the 5th is 3 to the 2 plus 5, or 3 to the 7th. All right, let's go to the next slide. Also, we might be using square roots too. So just if you want to say square root, you can just type SQRT. So square root 2 is square root 2. Okay, so yeah, so we'll also talk about roots. So there's root 4, and root 4 is also um, implied to be like the square root of 4. So you can see that if you go to the next slide, it'll be um, the 2 out there. And if it's a 3, that means like it's the cube root, fourth power, third power, fourth power. Um, and what this just means, these roots, is um, like what it means. So if square root, it's just saying what, so x, you make it so that it's like x squared equals 4, and then what is x? So um, if 4 is the square, then what is the, the original one? I'll ask you more to make sure that you're understanding this, but yeah, so if you just see this square root, it just means 2, like the square root. Next one. You can also say in general, so remember that anything to the 1 power is going to be itself. So if you wanted to, you could always put a 1 there. And something to note, this isn't obvious, but in the next one, yeah, you can say, if you have a square root, it also means kind of the denominator of the exponent. So if you see something like, square root of 4 to the 1, that's the same as saying 4 to the 1/2 power. So in general, square root of 4 also means 4 to the 1/2 power. Um, that is something that's going to come up a lot today. So just note that, if you have a square root, that just means that whatever root you're taking, it's going to be the denominator in the exponent. And also, by the way, next slide, this is all also a fancy way of saying 2. So
Can we have them? Can you message Coach Woma? So what is square root of 17? How do you write that with an exponent? The square root of 17 is equal to what?
please direct message me. Okay. Yeah. So yep. So it's 17 to the 1/2 power, and it's good that the people. So you would put a caret and then do like parentheses 1/2. So okay. So yeah, here's the question. What is the answer to this? And we would read this as, what is the cube root of 27? Or you can also read it as, what is the third root of 27? Please direct message me the answer to this. Okay, let's go to the next slide. So it is 3, and that's because 3 cubed, 3 times 3 times 3 is 27. Okay, let's do one. It's the fourth root of 32. What would this be? This might be a bit tricky. For anyone who sent me the answer to, try again. Yeah, so this might be a little tricky. Um, okay, so maybe let's go over this. Wonder if there's a whiteboard also. But we can go to the next slide first. So what I was looking for here for was so 32 is also 2 to the fifth. But because it doesn't like work evenly like our previous example, you can't just cancel out the 4 and the 5. So what some people sent me was 2 to the 5 fourths, and that's correct. So you can say 2 to the 5 fourths. But you can also if you have 2 to the 5 fourth, that's also just 2 to the 1 plus 1 fourth. Or you can also think of it like 2 to the 1 times 2 to the 1 fourth. And that's, or sorry, wait a second. Let me figure this out. Okay, I wrote this wrong actually. This should be times um, the cube, the fourth root of 2. So yeah, it should be 2 times 2 to the 1 fourth. And then, yeah, there should be a 4 right where the mouse is right there. So it'd be 2 times fourth root of 2. So does that make sense to everyone? Please give me a thumbs up, thumbs down if things are making sense. Thumb sideways if it's not making too much. It's like, some sense. Yeah, so the answer here should be 2 to the 2 times fourth root 2 because it's 2 to the 5 fourths, but you can pull out a 2 from there. Okay. Let's go to the next. Okay, so from all these things that I told you, there are some rules that you can um, have with the exponents and these roots. So we're gonna play a little game where we guess the rule. So you'll need to use like square root. You probably need to use like exponent. Um, so yeah, let's start this game. So remember to direct message me your answer. So a to the 0 equals blank. So please tell me what the question mark should be. So whenever you see things like this, where people say, oh, maybe like a rule, A can just stand for any number, basically. So you can see specifically here, it says A not equal 0. I'll get into that. Okay, so we can go next slide. So the answer was 1. So this basically is saying that any number to the 0th power is 1. And you might remember that from prime factorization. The reason why it says where a is not equal to 0 is because if you try to do 0 to the 0, uh, weird things happen. It's kind of like when you divide by 0. So as long as it's not, as long as your base number is not 0, um, anything to the 0 equals 1. Cool. Okay, so let's go to the next one. So a to the b times a to the c equals. So how would we complete this rule? Please direct message me. And if you're having issues, think of a as like a number like 2, b as a number like 3, and then c as a number like 4. Okay, we can go to the next slide. So this is, like we said before, where the exponents add. So a to the b times a to the c equals a to the b plus c. Cool. All right, let's go to the next one. What if you have a to the b divided by a to the c? I'll give people about 10 more seconds. All right, let's go to the next slide. So yeah, instead of being plus, it becomes minus. Yeah, so that's the rule for this one. Um, after a few more rules, I'll show you something that might make sense with that. So okay, so what if you have something like this, a to the b, and all of this is to the power of c?
Yeah, you can think of an example. Let's say you have 5 cubed and you're squaring it. Figure out how many fives do you have. And you could also list it out on your paper to see the pattern.
Okay, let's go to the next slide. So as most of you guessed, it is the rule is that you multiply the exponents. So it's a to the b times c, or sometimes you don't even see the times anymore, right? So uh, a to the bc also just means b times c. And I think with what Ms. Dewan suggested, this should make some sense. So you can think of it like you want to multiply a to the b c times. So you have a to the b times a to the b times a to the b times a to the b. You do that c times, and you'll basically be adding b in the exponent c times. And that really just means b times c. So, all right, let's go to the next one. How about a to the 1? A to the first power. Okay. Yep, so a to the first power is going to be a always. Um, so if you should have 2, that's like 2 to the first, it's all the same. What about a to the negative p? Cool. All right, let's go to the next slide. So this is 1 over a to the b. And this should make sense now. So um, if you have a to the b divided by a to the c, that's also a to the b um, times a to the negative c, right? So this division is kind of a minus. So when you think multiply with the exponents, you should think adding the exponents. And when you think subtracting exponents, that's divide. Or divide just also means subtracting exponents. Cool. All right, so let's go to the next one. Also, by the way, you can also think of it like, okay, so if you had a to the b, it's also just 1 over a to the negative b. This means the same thing. Cool. All right, so the c root of a to the b. What can we write this as? Think about what does it mean? You have a root. What does that look like?
Yeah,
Move it.
Coach Woma wants you to rewrite this as an exponent. And mm.
Okay, so let's go over this. So remember that this is a to the b over c, right? So um, when you have a root, that becomes the denominator in the exponent. So that is something that you should kind of just memorize. Maybe if people are interested, we can go over why this is. But it is something that you should know. So if you have to the c root, it becomes the denominator in the exponent. So a to the b over c. Cool. Okay. And then what about this? So if you have the e root of a to the b times the e root of c to the d, how can you um, combine these terms? Okay. Yep. Getting some good answers. So this is a bit tricky because basically there are things you can combine and things you can't combine. And a bit of a hint for this is that when you're done, you'll basically see um, each letter once.
You can also send Coach Woma your intermediate steps, like send him, how did you rewrite this? Like the eth root of a to the power of b. How do you rewrite that? as an exponent and then show him how you rewrite this part. And once you get those two correct, you'll be able to write the final answer.
Yeah, you can send me any intermediate steps, and yeah, I think some of you sent me something like similar to what I'll put here, but that's also good. Okay, I'll explain in a second. So yeah, please keep working on this a bit. Okay, we can go to the next slide. So what I was looking for was the eth root of a to the b times c to the d. Some people sent me a to the b over e times c to the d over e, and that's also the same. And I just want to let you know that you can put it all under the same root. And sometimes you might go actually the other way around. So you'll have, square root or whatever root of things multiplied together, and you can always split them out and multiply. Um, so, so this is just something to realize, and this will come up a lot in the questions that you'll be doing. Cool. So I think that's it for the rules. We can go to the next slide. Let's do a bit of review of what we did today. So a lot of the things I went over with you is very conceptual, right? The rules, this is how you might do things. But yeah, let's go into actual numbers now. So let's say you had this problem. Simplify 2 to the 5th times 4 to the 7th times 8 to the 3rd as a power of 2. So what is that? 2 to the 5th times 4 to the 7th times 8 to the 3rd equals 2 to the power of what? So let's take about a minute or two for this question. And yeah, when you're doing things, think about some of the rules that we used today. Okay, let's go until 7:09. Actually, sorry, 30 seconds. All right, let's go over this. So next slide. Yep, so the way of doing this is you might notice that 4 is also 2 squared in blue, you can see there. And 8 is also 2 cubed in yellow, you can see there. And you can substitute 4 for 2 squared and then 8 for 2 cubed. And now you have this equation. So once we're here, we just need to remember our rules. So if you have 2 squared to the 7th, that should be 14, because 2 squared to the 7th, you multiply, right? So 2 times 7 is 14. And the same thing for 2 cubed, 2 to the 3rd. to the third. So you have, so because it's to the third, so that whole thing cubed, you multiply and you get 9. 3 times 3 is 9. And once you have that, once you have all the same base and you're multiplying all of them, so you add the exponents. So 5 plus 14 plus 9, that's 28. So correct answer is 2 to the 28. Okay, next question is simplify the square root of 72. Right? Let's go to the next slide. Oh, okay, cool. So to do this, you should think back hopefully to the prime factorization of 72, and you'll get that it's 2 to the third times 3 squared. And once you have that, you can start pulling out squares from this. So you can pull out a 2, so 2 squared, and then you're left over a single power of 2. And then you can also pull out 3, 3 squared, and then you have no more 3's left in the under the square root. So you have a 2 pulled out, a 3 pulled out, and a 2 remaining. So the answer would be 6 rad square root 2. Some people also call it rad, so someone might say 6 rad 2.